Bismillahirrahmanirrahim. Welcome back to our course, Deep Learning for Computer Vision. Today we'll continue our work on the second part of this course, machine learning, and specifically we are going to talk about the learning methods in machine learning. So let's jump to our lecture and see what we can do. So the title of this lecture will be Learning Methods in Machine Learning. Let's jump to the content or the headlines of this lecture. As you see here, we have 4 different types of learning methods. We'll start with supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement machine learning. We talk about these 4 main types of machine learning techniques, and we'll discuss it in details, and hope you will enjoy this lecture and try to be concentrated, because it is one of the lectures in the heart of the machine learning understanding in deep learning. So let's go back to the machine learning. What is machine learning? We already defined that in the previous lecture. In machine learning, or shortly ML, is a sort of part or subset of artificial intelligence that concentrates and focuses on developing and producing models of algorithms and or systems that learn computer how to deal or to improve its performance when dealing with data by gaining knowledge from previous experience or previous training, let's say, or previous activities without being directly programmed for every task. So we do not need every time to learn the computer or to program it. We just need to train it on a specific issue or task, and we can next apply it and publish this network, let's say, or learning method, and use it for other tasks. Simply, we can say that machine learning learns or teaches the systems to think and understand like humans. This can be done, of course, by the help of the human and by the programming tools that humans are performing and developing. Also, in machine learning, it's generally we have a training system. It's a training system, so we have a data set of inputs and an output for each for this data set, and we try to train the system to learn the relationships in this data set using the training system that we are using. In this case, we are talking about a specific type of training. Then after that, we can apply to a new data that is not already labeled, or it's not known whether it belongs to a specific class, or we want to simplify our task also in predicting prices of houses or other applications, of course. So in machine learning, we can predict a massive amount of data. So it helps us to get an output very quickly and accurately about specific or profitable opportunities that can be handled or can be used. So in machine learning in general, we try to build a system. The system, after passing proper training, it will be useful for being used in other tasks to help us reduce time, improve the performance, and predict specific outputs and specific decisions. So what are the types of machine learning in general? We have mainly 4 major types or methods of machine learning. The first one is the supervised learning, the unsupervised, semi-supervised, and reinforcement learning methods. So under every category of these 4 classes, we have subcategories and so on. So now the exposure of techniques in machine learning and deep learning has been witnessed in every tiny and specific field of our lives, including social life, including, let's say, scientific, military, medical. All these aspects are covered, and you can everywhere, wherever you go, you can find a specific tool or a piece of system that is based on machine learning. Let's start with the first type, which is supervised learning. From its title, supervised. So there's a sort of supervision in this system. So in supervised learning, the artificial neural networks are guided by a supervisor or a teacher. What do we mean by this? So you, from the start, you have a specific knowledge about the input data and where it can be used, or what is the output for this input data, how you can gain a specific output value uh, from in advance. So it's a prior information about the behavior or the relationships inside the system. Next, you can try to clarify and highlight this data and let's say classify or apply regression to get a specific output for this specific input. So the network in general creates outputs based on inputs without taking into account the surroundings. So in this case, we take the relationships internally in the system itself. Now, by comparing these outputs to the teacher non-desired outputs, so you can have an expected output and an actual output. So you try now, once you have an output in your system after applying the learning, let's say stage or epoch, in this case, you can find that there's an error between the what is desired and what is the real output at this point. And here you can generate an error signal. Now you try to minimize this error as much as you can to get a global minimum, or to get this error being decreased as much as you can. So once you get the desired, let's say, level of accuracy and performance, you can stop and assume that your system or your machine learning has reached the desired task for this system. This means that in order to reduce this error, the parameters are going to be changed, and the stage will be in iterations, and it will stop once you get an acceptable level maybe of accuracy, or maybe a specific, according to a specific cost function that you are using in your application. This is a good demo about supervised learning. Suppose that you have input data. This is the data set. This is the input data set. We call it the input data set. Here we call it also labeled data. Why? Because we know from the beginning that this is the supervision. That, for example, this elephant, this is an elephant. This is the label, elephant. For example, this is a camel. Okay, and this is for, let's say, it's a cow here and here. So you can relate now. You can specify every input in the data set by a label. So we call it a labeled data set. This is just for demo applications. Of course, we have other types of applications. Next, you apply your data to the system, to the training. This is the training data set. You have also the labeled, you have the desired output, that for every input in the data set, you have a specific or desired output. And this is the idea of the supervision here. So the supervisor is defining this relationship between the inputs and the labels that are assigned to these inputs. Now you apply this system or this input to the machine learning that you are going to use, the algorithm. There's a bunch of algorithms that can be used in this issue, to get this task. And you continue by processing and iteratively repeating your process until you reach a specific, let's say, minimum or lowest error. In this case, you can classify the inputs as elephant, let's say camels, and cows. Now, you sometimes may get some errors here. So what we mean by that, that you may get, for example, this is an elephant. You may get in your system that the input will be an elephant, while the output will be, for example, a cow, and this will give you a sort of error. We try to minimize this error as much as we can. The process will be repeated iteratively until we reach a specific acceptable level of performance in this case. This is the main idea of the supervised learning. So in supervised learning, there is an input where the input is labeled with a specific label, which means the label is what is required or what is the required output to be for this input, and your system will be working according to this supervision, knowing from the beginning that this is the output given this input, and this will help you to build the relationships and to extend the features in or define the parameters in your system in order to use it again and again. So after finishing the training, as I have just explained here, we'll apply a new data set, which we call it usually testing data set, or a new input data set that is not labeled, and try to get benefit from the training system by applying to it unknown input, and this input will be classified according to this learning system into a specific class. We have different learning options for sure. We may define here, for example, we may define the loss or the cost function that will be used to minimize our errors. We may improve our system by applying different optimization algorithms. We can do also, we can change the learning rate, the required level of accuracy at the output, and other performance for sure. So this is the main idea behind all these topics in machine learning when using supervised learning. Let's have an example here, simplified one. Suppose that you have to build an image classifier to differentiate between cats and dogs. So you have two classes, either cats or dogs. Now you feed to your system a data set that contains cats and dogs in different positions, different colors, different types, large, big, small, medium, different sorts. And you, from the beginning, you know that the data or the animals in the input as cats and dogs are labeled as cats and dogs. So this is the main idea of behind the supervision. Now your system will try to learn that to classify the input if it is a dog as a dog and if it's a cat as a cat. Now after finishing the learning stage, the training stage, we can apply the testing stage where we apply new inputs, new dogs, new animals that were not being included. So new, not being included in the data set, And in this case, we try to see what will be the output, and we need to calculate and find the error and whether it's okay or not. If it's okay, we can publish and say that this system is working well and it can be used for different tasks, including classification of different images of cats and dogs into their categories or classes. So as you see here in this animation, this is, for example, you think that your system is learning that it's a dog. When you apply cats and dogs, you try to learn from these images what are. So now we are given a new dog. You can see that's a dog. As you see here, the dog is not included in these images. It's a dog playing with a small ball. So this is the main idea behind using the supervised learning. So of course, it's a classification task. Now, what are the types of supervised learning? We have different types of supervised learning. Mainly, we have either regression or classification. In regression tasks, we try to find outputs that are not categorical. I mean by categorical that it's a cat or a dog, it's an elephant or a camel, etc. So the output will be a real value. It could be in dollars, in price, or in weights. In numbers, so you have a numeric value. While in classification, this is one of the main differences between the regression and classification. While in case of the classification, we have a categorical output. This means, for example, colors for red, green, blue, etc. It could be whether we have in medical applications, for example, we have a disease or we don't have a disease. There's a tumor, there's no tumor. So we try to classify the inputs. In, for example, in electrical engineering, in PV panel let's say, a classification operating PV panels, we can see that this effective PV panel is an operative or non-operative. You may have a lot of classes, not solely for just who you not we are not always concerned with having only two classes for sure. We can apply this to a list of classes that may reach hundreds, maybe thousands of classes. As for example, when we use different systems in classifying images on the internet, like the techniques that will be and the networks that will be discussed in later lectures. Applications, you can find this for spam filtering, whether this filter, this input, let's say email is a spam or not a spam. In medical diagnosis, there's a tumor, no tumor, etc. In image classification, as we just mentioned in the example, in fraud detection, to detect whether this image is fraud or attacked, has been attacked maliciously, or it's just maybe some noise added to this image, and we try to detect whether we have fraud or not. For natural language processing applications, for sure, this is a long list of applications here, including the automatic translation of languages, converting speech to text, text to speech. All these things can be found in this sort of supervised learning applications. What are the types of supervised learning? There's a long list of applications. They will be discussed in the next slide, I think. The main and very popular type is the logistic regression technique. Here we can also see and find something like what we call it support vector machine. It's very important also. Random forest, decision trees, k-nearest neighbor, KNN, and naive. Here you can see these links or videos to find out and figure out what is the idea behind all these, let's say, algorithms. Every algorithm has its own advantage and disadvantage in terms of the complexity, in terms of the performance, etc. All these things are included in these techniques. Let's have a demonstrative example. Here we have input data. As you see here, raw data. The raw data is, as you see here, is not classified. Then you apply to first to data cleaning. Okay. Then it will be processed by your machine learning algorithm, supervised in this case. As here you have supervision. We repeat it again to see this is the input. This is the data cleaning. Then the processing, machine learning, performance, iterative process. We repeat we apply model evaluation to get what about the performance in classifying all these inputs at this stage here. Okay. So the evaluation is done here. So to see what is the performance of the model. And we get the output data being classified into specific classes. This is a classification task for sure. Here we have another option, which is the regression task, as you see here. So these are the main, let's say, classes of supervised learning. Again, another example. Here we have the input. This is it looks like a robot. This is the teacher learning. This is an apple. This is, and after learning, you apply new inputs and you ask for the robot to ask you ask the robot for defining or classifying the type of the input, fruit in this case. See here the joke here that this apple was not in the data set, which is strange in color and maybe the shape. However, the robot could use the relations and the parameters trained during this process to identify that this is or classify that it's an apple. Another example on SL or supervised learning. Suppose that you want to buy a house and you are concerned with many parameters in this case. For example, you want to firstly to define what is the size of the house that you want to buy. This is your input. A number of bedrooms, another input, the zip code, so the location of the place, and the wealth, how much you can pay for all these things. Now, after taking into account all these parameters, these inputs, you try to investigate relationships and the parameters inside the system that will define, for example, the size and the bedrooms. You want to get a fairly size, a more specific output or fine output. Now, for the zip code, you can take from it the vocabulary, and it will affect also the school quality. For example, your location will be will affect where is the house location. It will affect the vocabulary if you can sit close to the malls and to the markets, if it is close to schools, and the wealth, how much you have to pay in this case. After processing all these parameters, you can get the output a price for this house, and this will help you to find, let's say, um, uh, we can say an affordable, good house after applying such a system for diagnosing or let's say finding a specific or compromise solution for your output, for your task. Here, these are the inputs, and this is the output. And in between, we have these layers are used to help as hidden layers to help in defining the output, having the inputs x1 up to x4. This is a regression task for sure. It's a regression task. So this is our small system. Now we try to build a neural network or machine learning system to define the output. And here we have, according to the different sizes and bedrooms and these all parameters at the input, you can define the price in thousands of dollars. And once you can relate all these things, you can build or you can define your preferable, let's say, according to your wealth or your budget, you can buy the house. So the inputs as X here, the outputs as Y, and you see that all these points, small circles, blue and red are the inputs, and the red line is the regression line. This is the model that you are trying to build. And when you change the epochs, if you look here, so here we have, these are the inputs. Here are the outputs. According to each input has a specific output. And you have here to repeat the process many times. We call it as a stage or an iteration. It is usually, we'll talk about this later on. We call it the epoch. And if you look at the input as here as the system, as we increase the number of the epoch, we get better performance, and the regression line or the output model will be improved with the lowest errors. So now you can apply as your input X values to define the Y, which is the price of the house that you are trying to build, or you are trying to let's say buy. So this is a regression task example. And now if we go to the other part or the type of supervised of learning methods, it will be the unsupervised learning. So in this case, there is no supervision. So this type of machine learning is where the algorithm needs to discover by itself the patterns and relationships using unlabeled data. So you don't have a dataset containing labeled inputs or labeled data, and you try to discover the relations, the features or the patterns inside this unlabeled data, and try to get an output for the required output that you designed to have for your unlabeled input. So mainly there is no instructor is present to offer advice, which means that the model starts to search for patterns, relationships of the input to the system. Now, the primary goal of the unsupervised learning is to usually is to discover hidden patterns, as I have just said, similarities, relationships, to find clusters of the data, and many other purposes that can be used. We may use also different tasks like to visualize the data to apply the machine reduction, and more and more. Let's have an example. Simply, we have an unlabeled data, okay, and the outputs are the corresponding outputs are not given for sure. You need to feed the input to the machine learning, and the machine learning will do all the process for you. So this is the input data with no labels. You apply to the machine learning algorithm. You try to apply, for example, interpretation. You try to interpret and discover the relationships, the patterns, the features in this data. And using your algorithm, you try to build, using these tools, you try to apply processing and to distinguish or classify the inputs into, for example, in this case, dogs and cats. So the task again is similar to the supervised learning, but with no label data. Usually we use this type of systems where we don't have, we cannot afford data labeling. Why we can't afford data labeling? Because maybe due to the complexity or the difficulty in labeling this data. For example, the data maybe not available, not always available with labeled information. If you try to label your data, you will spend a lot of time, so it will be time consuming or maybe labor consuming, and this also simplifies our task. Instead of sitting down and providing data labeling large data sets, performing the operation as supervised, you can take this data, and maybe the size of data is smaller than the case in the case of the supervised learning. Next, you can build your perfect or super algorithms that can be able to distinguish and classify maybe or apply other tasks to the input data to get your outputs that you are looking for. So this is the main idea behind this unsupervised learning. In this case, you try to interpret the raw data to find the hidden patterns from the data itself. So next, you can apply suitable algorithms to obtain the output. As we have just discussed, in case of the unsupervised learning, the process does not require big hassle or big effort on data labeling and finding what we call the ground truth for the inputs. So what is this is a cat, this is a dog. You just need to apply the data as is without any previous knowledge about its class and apply the learning tool or learning algorithm. An example of this unsupervised learning. Suppose that you have a data set that contains information about purchases you made from the shop. So you have some data set about your purchases from the shop. You now, through clustering, your algorithm can group the same purchasing behavior among you and other customers. This means that you try, maybe your algorithm try to combine or group the purchasing behavior for you and for other customers in the, for the shop. And according to this information and this tool, this will help to the shop or the mall maybe or the market to potentially serve the customers without the need for predefined labels. So by reading the data of the sold products, you can, or the shop can now build or cluster, apply clustering to the purchasing of the people in the shop. For example, if you, for example, you go and buy some food like, let's say, burgers or maybe other stuff. Um, it, Mainly you will be it will be very simply predicted that you will buy, for example, some drink, maybe or water with your food. So this will help the system to apply clustering in a proper way. And this is just a simple example on how we can apply unsupervised learning by exploring the hidden information or relationships in your input data. In this case, the products that you are buying from the shop. Um, this for sure can be very useful for business development and getting benefits from having such information in this case. What are the algorithms that can be used in USL? The first one and the most important one is the clustering. So grouping of objects into clusters, into classes, or in a group of clusters, a group of objects in one cluster. This means that this object belongs to this cluster and doesn't belong to that cluster. And this is, or to that group. And this is the one of the main algorithms that can, or targets that can be used or can be targeted using USL. What else? Association. This let's see, objective can be in USL can be implemented or can be assigned when or can be used for finding the relationships between variables in the large data sets. So you try to find the relationships between the large data sets usually, and here you can define what are the set of items that can that may appear or can maybe relate to each other in the data set. This type of USL is very important in marketing applications and strategies and can be very effective. Dimension reduction. Sometimes you may have a high dimensional space or input data set, and you try to understand and cope the behavior or the relationships between the components in this data set or the samples by just applying lowering of the dimension of these spaces. This reduction in dimensions must be done with keeping a meaningful properties, the meaningful properties in the original dataset not being harmed or not being seriously changed. So you try to reduce the dimension while keeping the most important part of the information, the relationship or the patterns and features inside the components or the samples or the items in the dataset not being harmfully touched or modified. What are the very important or very familiar algorithms? We said that we have clustering as the first step. We just here list this type of USL algorithms just to know and understand what is behind the clustering. Here we have different types of clustering: exclusive, overlapping, hierarchical, probabilistic clustering. All these tools can be used in the clustering objective, or let's say target in USL algorithms. For association, we can find something like a priori algorithms. You can have a look on the internet and find a lot of specific information about this topic. In dimensionality reduction, very important tools and very popular, and they are used very extensively in the last 20 years. It's the principal component analysis, PCA, and the singular value decomposition, and sometimes the combination of both in one hybrid algorithm. Again, we can use this in many tasks. Uh, like NLP in medical anomaly detection to detect anomalies. Image and video analysis can be used, for example, clustering. When you look at, when you have to, when you search for a specific video, or you can find that you will get a list of proposed, or let's say, of a list of videos that can be on your computer, and you can select one of them. Customer segmentation. Customer segmentation means that you can use it in marketing to classify or to apply a clustering to the customers, and according to this information can reorder and sort the products on your shelves in this market according to this classification, or this this clustering. So all these things, these tools are very useful in many and very large and very large and list of applications in real social life, in medical, in engineering, etc. Very well-known algorithms. They are not all new. The K-means algorithm. I have the opportunity to work with this technique in the 1990 year, 90s, and I've got many results in image processing for specifically for video compression using the K-means algorithm, and we call it at that time the LVG. It's a very well known. So we call it also the vector quantization. The LVG is a K-means algorithm that used to apply clustering and to apply block quantization of the inputs and to apply compression to the image. You can read a lot of applications on K-means algorithm everywhere. Mean shift algorithm. Also can find what we call DB scan algorithm. A principal component analysis PCA is very important also. We have seen this also in the previous slide. Also in the independent component analysis, very different versions of the independent component analysis techniques can be found in the literature and on the net. These are good links to follow and to read about these topics in details. For the association, we have what we call the a priori algorithm, ECLAT algorithm, the epigrowth algorithm. These are very important and well-known techniques that can be used for learning, or for as machine learning algorithms in case of USL association. This is an example on clustering. I see that we have the data, the input, without being clustered, or without being all have the same color. We don't know which is which. In case of using the K-means algorithm, can go now and see specifically that we could get clusters of this data. So the K-means algorithm could apply clustering to this group of inputs, and the same thing for this one and for this one. Now, here in this example, the classification can be done, or the clustering can be done simply because we can see it from in our brains very easily. However, sometimes this is not the case, and we may get stuck with very complicated cluster, let's say data that cannot be easily clustered into specific clusters according to their behavior and relationships. Here we have, as we can see that we try to apply a specific output and specific cluster values. And here we have the error after clustering. So we get clusters and we try to find the error between the elements in these clusters. And here we have the total within cluster sum of squares. So this is the error defined in this case. And let's see what will be happening here. as we modify the clusters on the left-hand side, these are called the centroids. And when changing the belonging elements or components to each of these clusters, we can go further and reduce the error. As you see here, the error is going to be reduced, and this will lead to a reduction in this value, and the curve will be going down and down. As you see here, that it will be going down until we reach a specific value that is for us enough and useful to stop at a specific point after applying this sort of clustering and get the output clusters in this case, the final stage. Another example here, you can see that we have clustering and association rules. As you hear, the clustering is already explained. When we talk about the association rules, so when you have to buy some food, you may buy also ice cream, some drink, maybe other stuff, maybe after that you take some coffee. And all these things here are very useful in sorting or in specifying the or in clustering the customers in this market. And this is also will aid the benefits or aid the marketing in general. This is a demonstrative example on the tree decision task. Now, suppose that you have an input A. This input, you need to apply a decision to take an action according to this input. So you train it using the tree decision method or learning method. Here we have A and B are as numbers, while C is categorical or symbolic. So we start by giving values in a tree-like shape operations. Suppose that, for example, you take a decision here or making a condition that if A is more than or equal to 20, go to B. If otherwise, go to C. In this case, you select either high or low for C. And as a result, if you get, for example, high value, you will stick with the decision of a value of 1, which is on. Otherwise, you need to check further for the B value, if it is less than 40 or above 40. For 20, and you again take a decision according to these this tree-like operation. Similarly, you can go in this path or to get the final answers or the final decision that you want to make in this regard. Of course, this type of trees is usually, or this type of learning methods can be used for simplified or simple actions or tasks where there is no big complexity in dealing with the system. It can be also used or implemented in a hybrid way with other methods as a part or as a piece of the equipment or device or maybe the algorithm that will be included in this such system. We by this slide finished working with the unsupervised learning, and stick with your computer. The lecture is still on. We'll continue and go to the second part very soon. So see you soon.